Alright, welcome to this video. My name is Lucas Tavares and I am a RavenDB enthusiast. In this video, we will keep comparing the RavenDB experience versus PostgreSQL. In this case, I'm going to perform some actions like creating 3,000 beverages registries in the database from the zero. So I will get a clean database, RavenDB database, and a clean PostgreSQL database. I will run the same .NET API, and I will flag this to different databases, and then we can see the same methods, how would they respond comparing both database services. So let's do it. Right, first of all, I have to run RavenDB server. All right, here we are, clean database, and now, as I can see, the configuration file on my software, I must configure that environment variable to RavenDB to run it connecting to the RavenDB, right? So here, launch settings, here is my environment variable. So fine, let's go. Okay, here we have the documentation that is the same as the repository README, so you can read this to understand more details what I've done in this project, but let's get focused on the menus resources. So the first thing I should do is to bulk insert the data, then I can have data to explore the database differences. So let's start by this method. As I mentioned, it will include in the database at once using bulk insert 30,000 beverages that will vary between wines, whiskeys, and beers. So let's start. Right, fine. So what did we had here? We read a JSON text file that is embedded in my solution. And this has performed the bulk insert in RavenDB. It took 4 seconds to include all documents, right? So here we are. We have all the documents contain the beverages here. So as you can see, we have that fields that is our domain entity for beverages. So we have label, we have description, we had the type of this beverage and some other data control information here. These are counters. We will explore this further. Right, so being very quick here, I'm going to stop the application and I'm going to switch this to PostgreSQL. So I must make sure that the migrations would run. So the migrations are here created. I had the initial, I have the initial migration here and an improvement that I did on guest and social network. So what happens here? To start Postgres, it will add to the pipeline and then it will run that migration to database. After that, I'll follow the same schema, including a bulk insert. Let's try. Oh, wait. First of all, we must, of course, run the service for PostgreSQL. Okay, database is running. Now I can run this. Alright, so we can run the application, but before that, let me just open the PG admin. Let me just check this database and show that we are starting with a blank database. Okay then, so admin. Right. Here in tables, I don't have any table. I do have RavenDB demo here, and that's it. So we're clear to go. Let's start the application and see if the migration will work fine. Oh, the migration. Let me exclude this database and create all from the zero. Let me just do that here. Let's run again. Okay, the application is running properly. We can check here that the tables were created, schema, public, and tables. So here we have gas and beverages. Right, perfect. So let me do the same application here, the same resource method. We will create a bulk insert into PostgreSQL. Let's run this. Okay, we had a bulk insert. In this case, we read all 30,000 documents, and we could insert this in 3 seconds. We got 1 second more than RavenDB in this import, and that's fine. Okay then, so this was a comparison about the bulk insert itself. Now let me just query that information here. Okay, let's list. Where is that? All rows. Okay. Okay, here it is. A few of the documents here, all the columns created, and now we're good to go and query data, right? So this was a bulk insert comparison, and I'll follow to the next step. All right, so let's move on to the next comparison. So let me switch back to RavenDB. Let's start the application. So Postgres was 1 second faster than RavenDB to bulk insert all beverages, but we'll see the difference on the indexes. And let's do a second lap of race. So RavenDB has no index right now because it created indexes dynamically while I search for a query, specific query. So I'm gonna try to find Cabernet. Let's see the wines first. I'm looking for a wine. Okay, it might take a few seconds, and the indexes are already up to date for 30,000 documents, right? So it's all indexed. So by that, I took almost 5 seconds to query at the first time, but when I search that on the index, on a 100% ready index, the application would go really faster. Let's try Cabernet. All right, now I had 200 milliseconds to fetch. So let me try another word here, whiskey. Okay, right again to 200 milliseconds. And if I want to type, I don't know, a combination of fields like whiskey 2018. Okay, so combining that fields, 100 milliseconds. So that's it. I can also find for Italy. Right. So fetching is very fast. Let's go to the full text search on PostgreSQL. Let me just stop the application. All right. So let's switch back here. Now here we are. Full text search. Let me try wine. At the first time I had 1 second query, and if I query again like Cabernet, let's see, let's go 100 milliseconds to run. Okay, and now if I combine fields like whiskey 2018, 100 milliseconds. Yes, so I also had all that queries in in a page of 100 item size, right? So okay, so this is, let's go to the next comparison, and now things will become more interesting. I will fetch, let's run the application again, and I will perform something that we might look and see that I want to perform the counters resource, something that is native on RavenDB and it's impossible to create on Postgre. Let's suppose that I have a feature, a button in my interface that will like a beverage, because I want to like, each time I drink I want to like it, and if I dislike the drink I want to tap dislike it, and I want to count this all over the user experience through all the users. In Postgre I might have to create a table for that. Yes, I would have to create a table and create an update for that would create some concurrency, and this might be a little complicated. When we do that on RavenDB, what happens is that we have that counters detached to the document. So you will load the counter by the ID of this document, and you're able to perform a count. So let's do this here and count again, count again, count again, count again. So this is very fast. If I want to dislike this, before that, let's load that document. If I load the document here and retrieve the data, so 100 milliseconds to load, and here I have that like. You can see I have 5 likes, but I have no dislikes here. If I load another document that has no likes, it should not be displayed here in my API schema. Okay, here, right, no likes. Let's create some dislikes here and also like again. Likes and dislikes. Okay, 7 dislikes and 1 like, right? So we can create this here and load this document, and we will have both fields, likes and dislikes, right? So where is it saved? If I look for the database here, let's open the studio and look for this document. Counters, yeah, it's not in the middle of my properties. I can't find the number of likes or dislikes. This is something that I created in aggregation to make it easy to configure the counters names direct from the class. So I created this list inside it, but this is not necessary. I could simply delete this, and it would not affect the counters itself. And here we can delete, we can edit, we can filter these counters. I can add counters manually here, and I can retrieve that on the application side naturally, like an extra feature. So this is very important because we can create several kind of measures in the middle of the code without losing performance or without loading and locking objects unnecessarily. So this is very powerful, and this is nothing practical if we would do this into PostgreSQL. So before I start to the next step, I will do something here just to start the indexing as a vector, right, in RavenDB. Just hold on a sec. Let's just type wine here, and that's it. The indexes started to be updated. It's updating here. It will take a while. I'll grab some coffee.